Okay, we're going to sketch each of these, and we're going to state the amplitude, the period, and the vertical shift. And you can totally type this into whatever graphing utility you want to use. Desmos online, you can use a graphing calculator, and just make sure you're in the correct mode. This graph is, notice, look closely, it is not in degrees, it's in radians. So pi over 2, pi, 3 pi over 2, 2 pi, all that this is in radians. And this is the exact same equation we just had up here. So we're going to draw the exact same thing, only we're going to match it with the radians instead of the degrees. So let's just go ahead and start with what we know. This graph is going to start at 0, 0, because the other graph started at 0, 0. And at 180 degrees, Paul's right there, 180 degrees is pi radians. You can look at your unit circle and see that. 180 degrees is pi radians. And so we are going to touch right back there. And then at 360 degrees, which is 2 pi radians, we touch back right there. The highest this graph ever got was 1. And so what I personally like to do is draw the midline, which is kind of unnecessary because it is the x-axis. But the highest this graph will ever get is 1. The lowest it will ever get is -1 because, and I'm going to just go ahead and write some stuff that we actually just wrote, but I'm going to get in the habit of it as we go. The amplitude is 1. The period is something. We'll deal with that in a second. And the vertical shift, I will abbreviate that, is 0. So we are going to have one full cycle that goes all the way up. All right, pause right here. At pi over 2, we have a y value of 1, just like at 90 degrees we had a y value of 1. 90 degrees is pi over 2. It goes back down. Back to there. So the period of this, I would say it's 360 degrees. You wouldn't be wrong, but we are in radians, so it's going to be 2 pi. Okay, knowing what we're really dealing with and the fact that this is a sinusoidal graph, type it into Desmos, type y equals sine x for real, you'll see it. What you're going to see is a graph that goes on and on and on forever, so it's going to repeat. So everything that you just drew is going to repeat. So it took 2 pi radians to do one full cycle. So it's going to take 2 more pi radians all the way to 4 pi to finish the cycle. So it's going to go here. I'm going to make this one dotted. I don't know why. There's that. Now, it can keep going from there. We've run out of graph, but it could keep going from there. And it also can keep going backwards. So we can go all the way back to -2 pi and continue this pattern. And all this back here is an extra period. We had an extra period back here. We had the one that we drew, and then we had that other one as we move forward. And then it just continues. It continues forward. It continues backwards. Okay, we have dealt with translating graphs before, so everything you just did is going to be applied in this context too. Notice that this one is a little different because it says -2. You know what that does. You realize that vertical shift, horizontal shifts, all these kinds of things, and this is going to be -2, and it's outside any parentheses or grouping symbols or operations that are taking place. So this is a sine x, then -2. So we are going to have a midline not at 0, but at -2. So the middle of this thing is here. That is the only thing that changed. So while this one had an amplitude of 1, from the middle we go up 1, and middle we go down 1, we're still going to have an amplitude of 1. It's just going to be shifted down 2 units. So from here, we're going to go up 1. That's the highest this graph will ever get. And we're going to go down 1, and that's the lowest this graph will ever get. And we're going to start drawing. So let's draw. Here goes. We're going to start, all right, look where I'm pointing. We would start at the origin. I'm not going to start at the origin. I'm going to start at -2. And I would touch the x-axis again at pi. No, I'm not. But at pi, I will be shifted down 2. Everything is shifted down 2. Let's just draw one period first. And when we draw that, we'll see that it could go all the way up to here, and then down, all the way down, and then back up. That is one period. Let's go ahead and label everything. We have an amplitude of 1. That didn't change. We have a period of one full cycle taking place within 2 pi radians, and then we have a vertical shift. Green pen's dying. Oh no. We have a vertical shift of not 0, but -2. And then if you want to continue to draw a few more periods, you could, and I will. We would have a complete other period that goes from 2 pi to 4 pi, touches in the middle. So, and it does keep going. And then we can do the same thing back here.